So it says define acceleration. Okay, got to do my favorite student here, Anne Serkey. 2 marks. First of all, is acceleration a vector? Does direction matter? Yes, acceleration is a vector. It matters whether if you accelerate in the same direction as your velocity, you'll speed up. If you accelerate in the opposite direction of your velocity, you'll slow down. Acceleration is absolutely a vector. Define acceleration. I would take a lot of definitions. Certainly if you said change in velocity, or if you even said delta V over delta T, if you wrote change in velocity in symbols. Anybody else, holler it out and I'll tell you whether I like it or not. What else did you say for defining acceleration? Yep.
Rate of speeding up and going back.
Yep. It's how fast your speed changes. Sure. Anyone else? Okay. Probably this question would be multiple choice. Hint, hint. Multiple choice on your test. In other words, I'm not going to ask you to write the definition, but I'd probably give you 4 to pick from. Pick the best one, and they'd be pretty obvious. An accelerating body must at all times. You know what? That's the definition of acceleration. Doesn't have to have a positive velocity. You can have a negative velocity. If you're falling down, you're still accelerating. Doesn't have to have an increasing speed. You can be slowing down. That's also accelerating. We normally in English call it decelerating, but in physics we just call it all acceleration. Have a changing direction. Can, because that's another way to change your acceleration. Say whether your velocity is increasing or decreasing. Velocity is going forwards, accelerating forwards. Increasing. How about I for increasing, D for decreasing? Would that be clever? Going forwards, accelerating backwards. You know what? Going forwards, hitting the brakes, because that would be accelerating backwards. I think decreasing, yes? Velocity is negative. In reverse, acceleration is positive. In reverse, but accelerating forwards, that's actually hitting the brakes while you're in reverse. You will slow down. You will decrease. The other way to think about velocity is negative and accelerate. No, you know what? Brakes is the best. Velocity is negative, acceleration is negative. The best way to think about that is free fall. Which way is your velocity? Down. Which way is your acceleration? Down. What's happening to your velocity? Increasing or decreasing? Now, I always pause on C and D. On C and on D, it is possible for you to tell me that C, the answer is increasing, and that D, the answer is decreasing, if you give me the correct argument. So, if you said for part D, increasing, and you think you can defend that, I'll take it if you want to give me the argument right now. Did anybody say C was increasing? And if so, convince me. What did you think? Oh, Connor. Think what?
If your numbers are negative and they're going down.
Okay. So we have a problem here with negative numbers because really negative 1,000,000 is smaller than negative 100. It is. And so if you think about it mathematically, so I will accept for you, sir, if you said your answer for part C was increasing, I will accept that. And if you said that your answer for part D was decreasing, I will accept that. What I should have done for all of these was really what I should have said is, and then all we're talking about is the magnitude, not the positive or negative. Yeah. Quickly, buddy. Okay. Thank you, Connor. I was hoping somebody would spot that. What does the slope of a velocity? Hey, Mr. Dewick, this is from last unit. It's all physics. Shut up and deal with it. Hey, what is the slope of a velocity versus time graph? Really? Acceleration. I'm just going to write an A with a vector sign. That's my, that works. All right, now we got into some physics. They want acceleration decreases. What kind of an acceleration am I expecting if I'm slowing down? Negative. If I get a positive, I'll freak out. It looks like V initial is 25. V final is 5. T is 8. Hopefully, you're at the point now where you can rewrite these equations. I've thrown a lot of practice at you on purpose. I'm hoping some of you might even be at the stage where the equation in its modified form just pops right into your head without you having to do the rewrite. Yay, that'd be great. 5 minus 25 divided by 8. I can do that in my head because it's going to be negative 20 divided by 8 is negative 10 divided by 4 is negative 5 divided by 2. Negative 2.5? Is that right? Yes? Meters per second squared. How many marks is this worth? 2 marks. Same as always, 1 mark for the equation, half mark for the numbers, half mark for the answer. But if you got the right answer, Jess, 2 out of 2. Bus, I bet you I'm going to get a negative here, 2. Let's see. Bus is moving at 30 meters per second. That's V initial. T is 6. They want me to find A. There must be something else they told me because this isn't enough. Oh. Sheldon, what does that tell me? BF. Okay. A equals VF minus VI over T. If I was doing my job right, I'd probably pick Hedrick and I'd say something about if time gets smaller. No, actually, no. That was for time by itself. This is A by itself. I'll come back to you. 0 minus 30 divided by 6. Oh, that also works. Negative 5, yes? I guess technically I should go negative 5.0 because that there is 2 sig figs, but I'm not going to be that fussy again for your answer. I'll just do it that way. And meters per second squared. Looks like number 7, we want VF. VI is 103. T is 7.5. A equals, I've made a mistake. Does anybody see it? Yeah. Okay, I underlined that. I might try that once on the test, maybe once. I won't do that all the time. In other words, Alicia, if I ever give you a slowing down, most of the time I'll just make the acceleration negative when I tell you it, but I think there is going to be one question on your test where I say slows down. Please notice, I think I probably would have underlined the word slows down. Oh, this is straight plug and chug. VF equals VI plus AT. It's going to be 103 plus negative 5 times 7.5. Do that one in your head, Mr. Dewick. That one's yucky. Minus Mr. Dewick times 7.5. Do y'all get 65.5? Yep. 65.5 meters per second. How many sig? Probably technically 66. I should go to 2 sig figs because of the 5.0 and the 7.5, but whatever. How long will it take you to go from T. VI is 2, VF is 10, A equals 3.5. It's going to be VF minus VI over A. It's going to be 10, take away 2, divided by 3.5. 2.285, 2.3? Yeah? 2.3 seconds. What must your initial velocity be? Oh, some people were asking me about this. This was a mini curveball. This, Sheldon, is where my teaching you how to manipulate equations is worth it because it means I don't have to look at every single permutation. I can have you derive stuff on your own. Definitely this question is asking you to find VI. VF is 20. A is 3.2. T is 3.3. Now the equation is VF equals VI plus AT. Okay, they want VI. How would I get the VI by itself? I don't know if we've done this one before or not, but how would I get the VI by itself? Yeah. Can you say it with confidence and authority in your voice like it's boring and obvious?
Subtract
Oh, subtract AT for Pete's sakes, because we're plussing the AT, so we'll minus it over. So, okay, apparently the VF would drop down like a domino. I would subtract the AT. I'm going to put the VI equals on that side because that's where I like to have it. There is my new equation. It's going to be VF 20 minus 3.2 times 3.3. How fast did I start at? 20 minus 3.2 times 3.3. Apparently, I started out at 9.44 meters per second. Have I given you one where you had to find VI before? I can't remember. 1 mark, sorry. 1 mark for that. Half mark. Half mark. Hey, this is 3 marks. Probably means there's 2 steps. Oh yeah, in the hint it says you're going to need to find A first. You know what? I'm going to divide this question kind of in half. And I'm going to put my efforts to finding the acceleration first. It starts out at rest, so VI is 0. I would probably underline the word at rest. After 12 seconds, it's traveling 30 meters per second. Hey, I can find A. It's going to be VF minus VI over T. It's going to be 30 minus 0 over 12. I think I can do that in my head. 30 divided by 12 is the same as 15 divided by 6, the same as 5 divided by 3. Is it 2.66666666666? Yes? No? For the acceleration? People aren't giving me the nod. I guess I have to type it. 2.5. Wow, you're right. Sorry, whoops. 2.5. Thank you. 2.5 meters per second squared. So now I can walk over here. A equals 2.5. VI was still 0. They want me to find VF. This time T equals 7.5. VF equals VI. You know what? Courtney's looking at me. Mr. Dewick, why'd you bother writing the VI? That's a great point, Courtney. I could just go VF equals AT, couldn't I? It's going to be 2.5 times 7.5. 18 point, I'm going to go 18.8. 18.75 is fine. Mr. Dewick, what, Sheldon? Will there be like a 2-stepper on your test? Probably, and you'll probably know because probably it'll be worth 3 marks. That's kind of your hint. Okay. There will probably be a question where I ask you to find, or where you have to find something in order to find something else. What is the velocity? Oh, you know what? For each of these, they want V final, and it's just going to be AT because we're dropped. V initial is 0, and we're in free fall, so it's negative 9.8. Here T is 2. I think negative 19.6. Yes? And I think negative 9.8 times 6, that's going to be 50. I'm missing a decimal. I better do this one. Negative 58.8? Oh, meters per second, Mr. Dewick. Negative 58.8 meters per second. 2 marks for each of those. So that whole question is worth 4. Again, 1 mark for the equation, half mark for the numbers, half mark for the answer. For number 12 and 13, I told you guys, assume it's dropped. In other words, VI is 0. In fact, I think what it wants me to find is time, which is VF minus VI over A. VF minus VI over A. It's going to be negative 24.5 minus 0 over negative 9.8. Negative 24.5. I guess I don't need to type the minus 0. Probably didn't need to do the brackets at all. Oh, 2.5, yes? And it's going to be negative 63.7 minus 0 all over negative 9.8. I guess I don't need to type the minus 0. 6.5. Wow, I made those work out kind of nice. I usually don't do that. 2 marks for each of those. How far? Well, now they want a distance. D equals a half AT. t squared. Courtney, what happened to the VIT? We assumed it's 0. D equals a half AT squared. And you notice I'm not listing my data because they kind of did in part A. They wrote the t 2 seconds, and I know g acceleration is negative 9.8. So I'm being a little sloppy, lazy here, also because I'm trying to go really fast and finish over the test, right? So here we go. It's going to be 0.5 negative 9.8 2 squared. 2 squared is 4 times 0.5. Is it negative 19.6? Is that the answer for A? Yeah. Meters. And this is going to be 0.5 negative 9.8 6 squared. Oh, that one's a bit yuckier. 0.5 times negative 9.8 times 6 squared. Is it negative 176.4? Yeah? Really, I should say 180 meters. Negative and negative. If you didn't put the negative, because how far is sort of vague, it's tough to tell whether I wanted a displacement or a height. I wouldn't be fussy if you left the negative off, but yeah, we're falling down, so okay. 2 marks for each of those, and you've all turned the page, hopefully. I like number 14, I like number 14, I like number 14. Number 14 is a nice question. Number 14 is the same as the lab that you guys did yesterday, the reaction time lab. Really? Yeah. Say what? What am I asking you to find, Andy, in part A? What were you finding in the reaction time lab? Time. What's the acceleration? Negative 9.8. What was the acceleration in the reaction time lab? Negative 9.8. What did they give me? A distance, except I'm not going to write 533.3. Why am I not going to write 533.3? What am I going to write instead? Negative, because we're ending up below from where we started. Oh, you measured the distance in the reaction time lab. So this is actually exactly the same physics. It's just that in your reaction time lab, your distance was much smaller, like 0.23 meters or something, negative 0.23 meters or something like that. But it's the same equation. Oh, and VI is 0, dropped. So I end up with this, D equals AT squared over 2. Courtney, what happened to the VIT? What happened to the 1/2? It's there, see it? I just didn't bother writing the 1. Is that okay, Matt? What am I trying to get by itself? Times by 2. Divide by A. Now that gives me T squared. Square root it. This was exactly what you were doing in your reaction time lab yesterday. So we're going to get this. The time is going to be the square root of 2 times negative 533.3. By the way, that is how big the CN Tower in Toronto, Toronto is. Divided by negative 9.8. I think someone has base jumped from the CN Tower, and I think someone has bungee jumped from it. Of course, they wouldn't go all the way down to the ground, so they would never experience the full free fall time, but 2 times negative 533.3 divided by negative 9.8, square root, 10 point something, 10.4 seconds. A number of you, if I handed you back your reaction time lab and you had a reaction time of crazy small, it's probably because you forgot the square root. And then a number of you, if you had a reaction time, I think Jin and Justin, I think you guys forgot to convert your distances from centimeters to meters, and so you were saying instead of 22 centimeters that the meter stick fell 22 meters, which would give you a horrendous reaction time. Imagine if the meter stick fell for that long before you reacted. That means you're, nearly dead, right? So anyways, if you're wondering why some of the weird answers. How fast? Not 0! John was ready for it. I think you knew it was coming, yeah? VF equals... I'm going to use VL. Well, did I get A right? Am I sure I got A right? You know what? I'm going to go equals VI plus AT. I'm going to use my answer from part A because I'm just lazy. It's going to be 0 plus negative 9.8 times, I'm going to write 10.4, but conveniently, I listened to my physics teacher's rant about having a good calculator. I'm going to use my answer button. It's going to be negative 9.8 times answer button. You know what? It's going to hit the ground at negative 102 meters per second. Negative makes sense because it is going downwards when it hits the ground. You could also have used VF squared equals VI squared plus 2AD, where you would go 0 squared plus 2 times negative 9.8 times negative 533.3, and then you would say take the square root of that. You get the same answer, but you have to then realize what's the square root of 25? 5 or what's the square root of 25? 5 or negative 5. What's the square root of 36? 6 or you'd have to realize what's the square root of VF squared, VF or negative VF, and I have to now say, which one do I want? Okay.
15 was tricky, Mr. Dewick.
Yeah. How many marks? Probably multiple steps, probably, just thinking. I'm going to go like this, like this. I think 3 steps. First thing I'm going to do is I'm going to find how far you fall in 10 seconds. I'll call that D10. What will I call how far you fall in 1 second? D1. You guys cluing in? Subscripts can be an easy way to label stuff and stay organized. That's going to be a half AT squared. What happened to VIT, Courtney? Okay. So it's going to be 0.5 negative 9.8 times 10 squared. I can do that in my head because 10 squared is 100. It's going to be negative 980 divided by 2. Negative 400 and, good gosh, 60? No. Negative 400. That's wrong, Mr. Duke. Oh, good gosh, your brain is not what it should be. Didn't have my caffeine this morning, apparently. Negative 490. Of course it is. Negative 490 meters. Then in 1 second, I'm going to fall a half A1 squared. Okay, that one I can do because it's my 1 times table. 1 squared is 1. It's really just half of negative 9.8. Half of negative 9.8 is negative 4.9. And then it says, how many times further? What am I going to do with these numbers if I want to figure out how many times bigger D10 is than D1? I'm going to take those 2 numbers and do what? Divide them. And it turns out, is the answer it falls 100 times further? Yeah.
Mr. Dewick, how would you mark this?
I'd probably give you 1 mark if I saw that, 1 mark if I saw that, and 1 mark if I saw that. I think it's probably what I would do. Okay. Showing you all the stuff that we're capable of doing now. Truck parked on the slope, blah, blah, blah. How fast? VF is going to be VI plus AT. If you're parked, what's VI? Okay, so there's another physicsy, another word that I can interpret. So 0 plus 1.1, we're no longer in free fall, times 6.5. 7.15 meters per second. 7.2 if I went to 2 sig figs. How far? I'm going to use D equals VI. Oh, wait a minute. I'm just going to use D equals a half AT squared. Courtney, what happened to the VIT? Cancel, right? Okay. 0.5 negative. Oh, good gosh, I'm doing free fall. 0.5, that's a bad habit. 1.1, 6.5 squared. By the way, is this truck rolling forwards or backwards? Meant to be fairly, is this truck rolling forwards? I think I'm going to get a positive answer, I think. Yes? 0.5 times 1.1 times 6.5. Don't forget the squared. Did you get 23.23? 23.2? Meters. Andy, how many marks is this one worth? 3. I'll bet you I'll have to find something and then use that to find something else. In fact, I'm even going to anticipate, and I'm going to divide my page in half. I'm going to say, okay, they want me to find time. They told me starting from rest. They told me V final. Hey, Hedrick, is there an equation that has time, V final, V initial, and something else on the bottom of that equation? What else would I really like to find over here to find time? You know what? I'm going to say, even though this question is saying find time, what's this question really asking me to find? Acceleration. Hopefully in the first sentence there's enough. Let's see. VI is 0, standing start. T is 1.8. V final is 9.9. Woohoo! I can find the acceleration. A is going to be VF minus VI over T. By the way, I stole this one right from your homework from lesson 3 that no one asked me about, and I got suspicious. So I had a few people asking me, how do I do number 17? It suggests maybe they copied the answer from the homework. I don't know. 9.9 minus 0 divided by 1.8. I get an acceleration of 5.5. 5.5, and now T equals, what was it again, Hedrick? Oh yes, VF minus VI over A, because I remember, I seem to recall, if acceleration gets bigger, time gets a little small. Okay. 16 minus 0, I won't bother typing the minus 0. In fact, I probably didn't need to write it. It's going to be 16 divided by 5.5, 2.9, 2.91, 2.90 with the 90 repeating. I'm going to go 2.9 because I think it says 2 sig figs. Yeah. 2.9 seconds. Is that okay? Pardon me? Because it doesn't say that it changed. Because it says, look, accelerates at a constant rate. But by the way, I told you, I'm never going to change the acceleration in this unit because that requires calculus, and you guys can't handle that yet. Changing acceleration gets, but that's why, by the way, we can't handle air resistance, because air resistance, your acceleration is changing all the time, because as soon as you go faster, air resistance gets bigger, so it slows you down. But now you're slowing down, air resistance just got smaller, so you're going to speed up, changing acceleration. Aircraft starts from rest. I'd probably underline the word from rest. Accelerates at a constant rate. Andy, constant rate means the acceleration is not going to change at all. It wants me to find A. Let's see. VI is 0. VF is 48. T equals 12. Boy, we haven't used the D equals 1/2 bracket VI plus VF times T. We've used all the other ones, right? We've used VF squared. Okay, well, I hope it comes up. I was just making these up in my head. A equals question mark VF minus VI over T, 48 over 12, 4.0 meters per second squared. I hope, yeah, 4? Yeah. Last page, how fast is the plane going after 16 seconds? You know what? The acceleration stays the same, Andy, because it's a constant rate. So VF equals VI plus AT. I guess I didn't need to write the VI. It's going to be 4 times 16. I could do it that way and get 48 meters per second. Or, can I get VF a different way? Nope. I think I have to use my answer from part A to do part... Did anybody get part B without using their answer from part A? I guess no, they didn't give me a distance, did they? So I can't use anything with a D in it. VF squared equals... No. I guess I got to do that one. Yeah, am I wrong? 4 times 16 is 64 because I can't do math in my head. I did 4 times 12. Thank you, Connor. Did you say 64? That's what I wrote. You guys need to learn to read my writing. Man, I can't believe you can't read my writing by this time of the year. Yeah, I'm putting this one on the internet too. I've committed to warts and all. When I make mistakes, the world finds out. How far? Okay, that's a distance. You know what? Since I'm already using stuff that I've already calculated, I'm going to keep going with that. I'm going to use VIT plus a half AT squared, although Courtney is screaming at me that I could have just done that because we started at rest. So it's going to be 0.5 times, what was the acceleration I calculated? 4 times 15 squared. Maybe I can redeem myself. 15 squared is 225. 4 times 0.5 is 220. 550? 450. 450. 450. I forgot to carry. I carried a 1 when I didn't need to. Almost redeemed myself, but then I made another mistake. Good gosh. A equals VF minus VI over T. I think it's what I'm using for this one. What's VF? 10 minus, what's VI? Oh, by the way, am I slowing down or speeding up? Am I expecting a negative or a positive acceleration? If I get a negative, I'll smile. I won't freak out, right? 10 minus 15 divided by 3.25. Negative 1.538, negative 1.54. Nearly done. You guys have been very patient. Okay, they want me to find A. VF is 0 because it says brought to rest. VI is 42. D equals 5. Here we go. I have to use the squared, the VF squared. You know what? I'm going to use A equals VF squared minus VI squared all over 2D. It's going to be 0 squared minus 42 squared all over 2 times 5.7. Gesundheit. 0 squared minus 42 squared all over bracket 2 times 5.7. Did you get negative 155 meters? No, negative 155 meters per second squared. That's the biggest. No, you know what? This is a motorcycle crash. That should be a big acceleration. How many G's is that? 15 G. Oh, he'd probably break a bone, but he'd probably survive. Is it negative 155? Yes? Negative, because we're slowing down. 155 meters per second squared. Yeah, those numbers are legitimate. 42 meters per second, that's about 80 miles an hour. That's about 120 kilometers per hour. That's motorcycle racing speed. Okay. This one I only saw a couple of weeks ago. It came across my internet feed. On August 29th this year, a world record was set by cliff jumping from a height of 58.8 meters into water. How fast was the jumper traveling when he hit the water? If you go cliff jumping, you need to use your imagination. What's your VI? You're dropping, right? They want me to find VF, free fall, negative 9.8, and they gave me a distance, 58.8. I guess I'm going to use this one. VF squared equals VI squared plus 2AD, and then I'll square root to get rid of the VF squared. By the way, you'll notice, John, just because I'm using the squared equation doesn't mean I square root every time. I don't square root to get the A by itself because it doesn't have a squared on it. I only square root when my variable has a squared on it, and that's always my last step. It's going to be 0 squared. I'm not going to bother writing that. 2 times negative 9.8 times 58.8. So I go to my calculator, I go 2 times negative 9.8 times 58.8, and I square root that. And, huh? Yes, I did that on purpose this time. What did I forget? And again, if your calculator gives you this weird math error, whatever yours says, what do you go check? What's the first thing you go look at? Yeah. Where? Yeah, why? I missed a negative in my data. What did I miss? It's a displacement, okay? So if that happens, first place you go check is that there, which gives you that there. So really, this should be negative 58.8 square root. 33.9 meters per second. No, that's wrong. Because what's the square root of 25, Alex? Plus or minus? What's the square root of 36, Alex? Plus or minus? What's the square root of VF squared? Plus or minus VF? I want the negative one because I can imagine, I'm pretty sure a cliff jumper, when he hits the water, is traveling down. So negative 33.9 meters per second. How long was he in the air for? You know what? I'm going to use this. I could use my VF from part A, but this is good practice. What happened to the VIT, Courtney? Okay. You know what? This is the reaction time lab that we just did. To get the T by itself, it's times by 2. Oh, let me point something out. Some of you on your reaction time lab, you put a 0.5 instead of a divided by 2. So how would I move the 0.5 over? I could divide by 0.5 and divide by a, dividing by 0.5, dividing by a half. That is the same as timesing by 2 on the top. So either of those approaches will work. I just don't like having a decimal inside of a fraction if I can avoid it, although I will if I have to. How to get rid of a squared square root. It's going to be the square root of, what was D? Negative 58.8 divided by 0.5 times negative 9.8. Square root. He wasn't in the air for 12 seconds because that would mean he was falling from further than the CN tower, because if I recall, the CN tower was like 10 seconds. So in the air for 3.5 seconds. C. If the water took 3.5 meters to bring the jumper to a stop, so he went 3.5 meters into the water, and we're going to assume the acceleration is constant, even though technically it might not be, because if he spreads out while he's in the water, that's going to change his water resistance. We don't have the ability to deal with that. What was the deceleration? You know what? This wants A equals question mark. V final is 0 this time because it brings him to a stop. D equals 3.5 meters. Negative, I'm not sure. I'm going to look and see whether I need to make this one negative or not, because I know you're ending up below, but we're decelerating. We're going to come back to that. What else do I know here? Oh! V initial when he hit the water was negative 33.9 meters. Okay. I can use that because I don't know how the time. I know how long he fell for, but that's not how long the water took to bring him to a stop. I'm looking for an equation that has those. I think I'm going to use A equals VF squared minus VI squared all over 2D, which is going to be 0 squared minus negative 33.9 squared all over 2 times 3.5. By the way, when I square a negative, will that make a difference at all? What happens when you square a negative? It vanishes. I'm not going to bother typing that in my calculator. I'm that lazy. I'm going to go bracket 0 squared minus 33.9 squared. You know what? I see I'm going to go minus 33.9482, because that's the velocity. I'll use a few extra sig figs just to be more accurate. Squared divided by 2 times 3.5. Oh, when he hit the water, was he slowing down or speeding up? What did the water do to him? Slow him. So I don't mind a negative acceleration. Now, you could also say technically he's accelerating upwards, and if you did that, then you would make the displacement negative. But you know what? I'm good with this. Negative 164.64. If you got a positive 164.64, Jess, I would accept that. It's just you decided to let up be positive and down be negative, or I decided to let slowing down be negative and speeding up be positive. How many G's? Oh, how do I convert this? Oh, while in free fall. This is easy. How many G's did the jumper experience while he was in free fall? 1. That's why we call that negative 9.81 G. While being stopped, how do I take an acceleration and convert it into G's? Who remembers? Negative 16.8 or positive. You know what? I'm just going to say about 17 G's. 1 mark for each of those. Mr. Dewick has a video of this. Put your pencils down. Keep the numbers handy in front of you.